Okay, let's see. All right, number one, if this is 14, A is also 14 because opposite sides are congruent. Opposite sides of a parallelogram are congruent. Okay, if this is 8, and we know that diagonals bisect each other, so if this is 8, B is also 8. Diagonals bisect each other. Okay, if this is 78, then this is 78 because those are alternate interior angles. Okay, this is a straight line, so this is 180 degrees. If this is 110, that has to be 70. 180 minus 110. Here we're solving for x, and these diagonals bisect each other. So this must be equal to this. So we'll set that up. 2x plus 10 is equal to 5x minus 32. Bring this over. 5 minus 2 is 3x. Bring that over. 10 plus 32 is 42. Divide by 3, and we got x is equal to 14. Okay, in a rhombus, the diagonals bisect the angle. So because this bisects this angle, these two are the same. So 6x plus 32 must be equal to 17x minus 1. I'll bring the 6 over this way. 17 minus 6 is 11x. I'll bring the 1 this way. 32 plus 1 is 33. And I'll divide by 11 and get x is equal to 3. Okay, now, if this is 110 in a rhombus, this is also 110. And further, we know that, so this entire angle is 110, but this diagonal bisects this angle. So this 5x is half of 110. So 5x equals 110 over 2. So 5x equals 55. So x equals 11. All right, if this is 90, these two have to add up to 90. So x plus 55 equals 90. So x is equal to 35. Okay, I'm going to call this side x, and I'll call this side y. All right, now, x times root 3 is the longer side. So x root 3 equals 6. I'm going to divide each side by root 3. And I'll get x is equal to, now I'm going to multiply by root 3 over root 3. And we're going to get 6 root 3 over 3, which is 2 root 3. So this is 2 root 3. And then the long side is always double the shortest side. So this is twice this, which is 4 root 3. Okay, these are 45s, so these are isosceles. So in other words, if we call this x, then this is also x. And remember that x is equal to 12 divided by root 2. And I'm going to multiply by root 2 over root 2 to simplify. And we get 12 root 2 over 2, which is 6 root 2. So this is 6 root 2. And this is 6 root 2. And you can double check in your head. If you multiply this by root 2, you'll get to 12. This is a 30, 60, 90 triangle, so the short side is always half the hypotenuse. And the long leg is always this times root 3. If you happen to remember a 7, 24, 25 right triangle, that's fine. You can see that this is 7, but most people won't remember that. So let's go through the work. I'm going to say x squared plus 24 squared is equal to 25 squared. And I'll get a calculator out. 24 squared is 576. Oops, what did I just do? is equal to 25 squared, which is 625. So that means x squared is equal to 625 minus 576, which is 49. So x is equal to 7. Here, these are the legs. So x squared plus 4 squared is equal to 8 squared. So x squared is equal to 5848. So x is equal to the square root of 48. This is 16 times 3. Take out the 16 by square rooting it and get a 4. So this is 4 root 3. Okay, this is a 45, 45, 90 triangle, an isosceles right triangle, and the hypotenuse is always root 2 times one of the legs. So this is 9 root 2. All right, if this is 5, then this is 5. And here, if you memorize that there's a 5, 12, 13 triangle, you'll know this is 13. But if you didn't remember that, just use Pythagorean's theorem. So 5 squared plus 12 squared is equal to x squared. So x is equal to the square root of 169, which is 13. Okay, here are the legs. So 7 squared plus 14 squared is equal to x squared. 14 squared is 196. Add those together, and we get 245. So now, x is going to be equal to the square root of 245, which is the square root. Now, I know it's divisible by 5, so I'll take out a 5, and I divide it on a calculator, and I see it's 49. So we take out the 49, and we get a 7, so this is 7 root 5. Because this is a square, we know that this is an isosceles right triangle. In an isosceles right triangle, one of the legs times root 2 is equal to the hypotenuse. So we'll start there. X root 2 is equal to 4. I'll solve by dividing by root 2. And I'm going to get x is equal to, and I'm going to multiply top and bottom by root 2. And we're going to get 4 root 2 over 2, which reduces to 2 root 2. Okay, here are the legs. So 5 squared plus 5 root 3 squared is equal to x squared. 25 plus, now when we square this and get 25. We square this and get 3. 25 times 3 is 75. So x squared is 100, so x must be 10. Actually, this would have been a whole lot easier. If you notice, if this is a right triangle and the two legs is one leg times root 3 is the other leg, then you know this is a 30, 60, 90. And in a 30, 60, 90, the hypotenuse is always double the shorter side. So we could have gotten to 10 without using Pythagorean's theorem if you had noticed that. Okay. We have a 30, 60, 90 triangle on top and a isosceles right, a 45, 45, 90 triangle on the bottom. So let's use this to find these sides here. So if this is 30, 60, 90, this must be 8 because 8 times root 3 is 8 root 3. And the hypotenuse is always double the shortest side, so this is 16. And then on the bottom, we have a 45, 45, 90. So this right here is the hypotenuse. So x times root 2 is equal to 16. And I'm going to divide by root 2. And I've got x is equal to, now I'll multiply top and bottom by root 2. And we'll get 16 root 2 over 2, which is 8 root 2 for that side right there. Okay, let's first verify that this is in fact a triangle. The sum of the two shorter sides is greater than 11. 16 is greater than 11. So we know this is a possible triangle. So now we'll take the hypotenuse, the longest side, I shouldn't say the hypotenuse, but the longest side, and we'll compare the square of that with the square of the sum of the two shorter sides. This is 121, 64, and 64. 121 is less than 128, so this is an acute triangle. Okay, first of all, 16 plus 17 is greater than 20, so this is a possible triangle. This is the longest side, the 20, so we'll compare the square of that with the sum of the squares of the two shorter sides. 20 squared is 400, 16 squared is 256, 17 squared is 289. When I add this up, well, I can see 200 plus 200 is 400. So I know that this is 400 is smaller. Since this side is less than the sum of those two sides, this is also acute. Okay, you can just pop this into a calculator. It's a little over 5. 5 plus 3 is 8 or more than 8. That's more than 6. So this is a possible triangle. And I know that this is a little more than 5. So this is the longest side. So I'm going to compare the square of this with the square 3 root 3 squared plus 3 squared. Well, when we square this and get 9. We square this and get 3. 9 times 3 is 27. This adds up to 36. 6 squared is 36. Because these are equal, this is a right triangle. Okay, here, the sum of the two smaller sides is 14. It's not quite equal to 15, so this is not a triangle. Okay, we're missing, this is A over here. Anyway, this is ABC. In order to figure out if this is what type of triangle it is, I need to know this entire side, and I need to know this side. So let's start with that. If this is 5, this is 5. This is an isosceles right triangle, so this is 5 root 2. Okay. I'm going to write this in so we can see it. This is 5. Now, I can see that this is a 5, 12, 13 triangle. If you don't remember 5, 12, 13, you have to call this something and solve for it. So let's call this, like, say, x. Then 5 squared plus x squared is equal to 13 squared. That's Pythagorean's theorem. So this means that x squared is equal to, we'll move this over, 169 minus that is 144, so x is equal to 12. Now, again, if you remembered 5, 12, 13, you could have said this was 12 without doing any of this. But now we know this is 5 and this is 12, so this long side is 17. Let me just kind of fit this in here. From here to here is 17. So I'm going to compare the square of this with the sum of the squares of these. So we have 5 root 2 squared plus 13 squared. When I square this and get 25. I square this and get 2. 25 times 2 is 50. When I square 13, I get 169. And when we square 17, we get 189. Let's see, adding these up is 219. So 289, 17 times 17, what am I doing? Sorry, 17 times 17 is 289. All right, 289 is greater than 219. That makes this an obtuse triangle. And by the way, we know for sure that it's a triangle because the sum of these is bigger than 17. You can just see 5 plus 13 by itself is already bigger than 17. So 5 root 2 is even bigger than 5. Okay, the median AD, we first got to draw a midpoint. So I'll put a midpoint here, and I'll call that D. And then I'm going to get a ruler and draw from A to D. And just remember, you need this and this to show that this is the midpoint of this. These need to be there. Okay, the altitude IK. Well, here's I. And I need to hit this other line, but I'm not going to be able to hit it inside of the triangle because I won't be able to create a right angle there. So I need to hit it outside the triangle. So the first thing I'm going to do is extend this line. And I'll extend it with a dashed line. Okay? Now, I'm going to take this point and hit this at a right angle. So something like this, I think. And a couple of things I got to do. I got to draw a dot there and call that K. And then I've got to do this to show that it's hitting at a right angle. Okay, first let's graph this. -5, -4 is right there. We'll call that point W. -1, 2 is here. We'll call this O. And 5, -2 is here. We'll call that N. And then I'm going to connect these. Something like that. Something like that. And something like this. Okay. Now, I need to show that this is both isosceles and right. So let's do the isosceles part first. That means that we need to show that the length of this is equal to the length of this. So let's find the length of WO. WO is the square root of the difference of the x's. -5 minus -1 is +1 squared plus the difference of the y's. -4 minus 2 squared, which is equal to the square root of 4 squared plus -6 squared, which is equal to the square root of 16 plus 36, which is equal to the square root of 52. I'll just simplify that. That's 4 times 13, so 2 root 13. All right. And I put W, but we need to put WO. Okay. Now let's figure out the length of ON. The length of ON is the square root, the difference of the x's squared, -1 minus 5 squared. It doesn't matter which way you subtract, because after you square it, you'll get the same answer. Plus the difference of the y squared. 2 minus -2 is 2 plus 2, which is the square root of -6 squared plus 4 squared, which is the, well, let's write it down here, I'm running out of room, which is the square root of 36 plus 16. We already know that the square root of 36 root 16 is going to simplify to this. So we can see that WO is congruent with ON. Therefore, this is an isosceles triangle. So I can do this. Okay? Now, to show it's a right triangle, I need to know the slope of this and see if it's perpendicular to the slope of this. So let's figure out the slope of WO. Y2 minus, here's Y2 minus Y1, so 2 minus a -4 over X2 minus X1. -1 plus 5 is 6 over 4, which is 3 over 2. The slope of, and now we're doing this one, ON. So here's Y2 minus Y1, -2 minus 2 over X2 minus X1. 5 minus -1 is 5 plus 1, is a negative 4 over 6, which reduces to a negative 2/3. So I can see that these are perpendicular to each other. So let's see, WO is congruent with ON, and WO is perpendicular to ON. Therefore, triangle WON is an isosceles right triangle. Okay, let's first graph this. 4, 9 is right there. We'll call that point T. 2, negative 7 is the point right there. We'll call that point O. And negative 2, 3 is the point right here. We'll call that point N. And then let's graph this. Okay. All right, now graph the median NA. Well, here's N. The other side is this, so A is going to be somewhere over here. It looks like it's going to hit there, but let's just double check. We need to know the midpoint of TO. So the midpoint of TO, the X value of the midpoint is 4 plus 2 over 2, which is 3. The Y value of the midpoint is 9 plus negative 7 over 2, which is 2 over 2, which is 1. So the midpoint is 3, 1. So let's draw the midpoint. Go 1, 2, 3, 1, and it's the point right there. And we'll call that A, and we'll draw a line from N to there. And that's the median NA. Okay, the altitude TB. Well, here's T, so it's got to hit the other side, but it's got to hit it at a right angle. I'm not able to hit it at a right angle inside the triangle. It's going to come out here. So the first thing I got to do is extend this line because the altitude is going to hit it out here somewhere. So I'm going to grab my ruler and I'm going to lay it along NO, and I'm going to just with a dashed line extend this out. I'm not sure how long I need right yet, but now I need to come across and hit this at a right angle. So in order to know where the right angle is, I need to know the slope of this so I know the perpendicular. So let's start with the slope of ON. The slope of ON is y2 minus y1. Here's y2 minus y1. 3 minus negative 7, so plus 7 over x2 minus x1. Negative 2 minus 2. So we have 10 over negative 4, which reduces to negative 5 over 2. So we know the slope of the perpendicular is the opposite reciprocal. Now, if I try to rise up 2, I'm going to go off the graph. So instead I'm going to do the opposite of the rise, but the opposite of the run. So down 2, left 5. 1, 2, 3, 4, 5 is the point right there. So now I know that it's coming off of this through that point, and when I draw this, this is TB, so I have to label this point B as in boy, and I have to show that it's a right angle by doing that. Okay, the perpendicular bisector of ON. Well, first of all, we have to know the slope of ON, which we already figured out in the previous problem. So I'm not going to do that work again. I know the slope of ON is this. So the slope of the perpendicular is 2/5. So let's just write that in. The slope of the perpendicular is equal to 2/5. Okay, now I need to know the midpoint because it's a bisector. I need to know the midpoint of NO. So let me give myself some room here. Midpoint of NO or ON, it doesn't matter what you call it. The x value of the midpoint is the sum of the x's, 2 plus -2 over 2, which is 0. The y value of the midpoint is the sum of the y's, -7 plus 3, which is -4 over 2, which is -2. So the midpoint is 0, -2. So 0, -2 is the point right here. And now from that point, I've got to do this slope. Rise 2, run 5. And that'll bring me right here. So now I have to draw this. Remember, a perpendicular bisector has arrows on either side of it. So I have to put arrow here and an arrow there, and then I have to show that this is a bisector by doing this, and I have to show that it's perpendicular by doing that. You need all of these things for this to be correct. You need that to show there, and you need that right angle symbol there. And that's it.